All right, hello everyone. Welcome to the second week. We are doing lesson 3. This is the first lesson where it will be something completely new. Okay, what I first want to bring to your attention here, and I'm going to do it down here at the bottom, is before we left for our spring break and then our extended spring break, we had factored a few problems that look something kind of like this, x squared minus 25. And we factored those by going, hey, I have an x squared, I have a 25. I can actually, because there's no GCF, I can put a 0x here. And when I make a MA chart, I could say, hey, we are multiplying to negative 25 and adding to 0. And then we would find those factors of 25, which are 5 and negative 5. Right? Because those are what add to 0, and we would put them in here. So plus 5x minus 25, whatever order you wanted to put them in, okay? We would group them, and we could take out of each group their GCF. And so that now I have this answer, x minus 5 and x plus 5. What I'm going to show you today is a faster way to do that question, where it takes about 20 seconds, and that's about it. Okay? So, first off, we are factoring difference of squares. Okay? A number is a perfect square if it comes out to an integer when you take the square root of it. So you can check to see if a number is a perfect square by trying to square root it. Okay? What I want you to do is I want you to list your perfect squares. Now you can't really see them all down there. Let me see if I can get it all the way to 15 for you. Nope. Okay, let me see if I hit down what happens. There we go. I want you to write out your perfect squares list of 1 to 15. So I'm going to pause here and I'm going to let you do that. Alright, so there are those perfect squares from 1 to 15. Okay. So the numbers that we would be looking for here in a minute are the 1, 4, 9, 16, 25, those type of numbers. But we did need to know what they were as a perfect square. Now, on the other side of this here, I have our variables that are squared. Okay, so our variables squared, well, if I take just x and I square it, well, it's just x squared. If I take x squared and I square it, well, that means I need to multiply those exponents, so that is x to the 4th. X to the 3rd squared is x to the 6th. X to the 4th squared is x to the 8th. If I were to keep going, my next one will be x to the 10th, x to the 12th, x to the 14th. Pattern here, an exponent of the even power is a perfect square. Okay, so now to the meat and bones of today. Difference of perfect squares. So the first thing here, it says, what does the word difference mean? Okay, well, difference in math means to subtract. Maybe, if I can, there we go. Subtract. Okay, so difference means to subtract, or it means minus. Okay, so whenever I see two perfect squares, so here's an example. I just put a squared and b squared, pretty simple perfect squares, with a difference or a minus in between. Okay? Each time you have a difference of perfect squares, so a squared minus b squared, it will always factor this way. Well, what is the square root of a squared? Well, the square root of a squared is a. So what I'm doing here is I'm making my two factors. Okay, so I'm making two factors. Square root of a squared, so the square root of a squared is a. I'm going to put that at the beginning of both. Okay, the square root of b squared is b. Now, all I have to do next is one has to be positive and one has to be negative, so that when I multiply those together, I would end up with a difference of squares. Okay, so pretty simple. I don't have to do a 0 in between. I don't have to do grouping. I can just go straight to my factors A plus B, A minus B, one's a plus, one's a minus. They look exactly the same, and it's done. Okay, so examples. Here's the first one, x squared minus 9. Okay, so I'm going to first check, as always, is there a greatest common factor? Okay, no, x squared and 9 do not have a greatest common factor. Okay, so that means I have two terms here, and each of those terms is a perfect square. I know that because if I square root 9, it's 3. Okay, so I can do this. Well, what's the square root of that first term? Well, the square root of that first term is x. Okay, what is the square root of that second term? It's 9, or 3, I mean. So the square root of the second term, 9, is 3. So I'm going to put a minus in one of them and a plus in the other, and I'm done. Now, as always, you can check your answer by multiplying these back together. Okay? Now, it also does not matter which one has the plus and which one has the minus. As I work through these remaining examples, if you want to pause it after you see it, and then try it on your own and then play, you are welcome to do so through the rest of these. Okay? Here is the next one. Y squared minus 16. So first, is there a GCF? No, there's not. Now I'm going to look, are they perfect squares? Well, y squared, yes. 16, can I square root it? I sure can. So, pretty simple. I go right to my double parentheses here. Square root of this first term is y. The square root of the second term is 4. Now remember, this is only working because I have this negative in between them. Okay, and it does not matter whether I put the plus first or the minus first. Now, sometimes what can trick people is right here, 4 is a perfect square. But because y is not, we do not continue. This is our answer. All right? So, next example, m squared minus 81. So, are they perfect squares? M squared, yes. 81, yes. There's a difference. Yep. There was no GCF to start with, so I can go straight to my double parentheses. M square root of 81 is 9. And I'm going to add a plus in one of them and a minus in the other. And again, 9 is a perfect square, but m is not, so I do not continue. Alright, number 4 here. 9n squared minus 64. So first, is there a GCF in these? No, there is not. Okay, so now, are they perfect squares? Well, 9 is a perfect square, and so is n squared. That means together it is a perfect square. 64, again another perfect square, and guess, there's a minus in between. So, the big question here now is, what is the square root of 9n squared? Well, 3n, so both terms must have a 3n. Square root of 64 is 8. And so I'm going to put a minus in one and a plus in the other. And there's my answer. Number 5, 2w squared minus 98. So first, is there a greatest common factor here? Yes, 2 and 98 do have a greatest common factor. They have a 2 in common, so I can take out that greatest common factor first. So that it's w squared minus 49. After I have taken out the GCF, I can look at my terms and say, okay, is w squared a perfect square? Sure is. Is 49 a perfect square? Yes. So, final answer, 2. I can go right to my set of parentheses here. W, what's the square root of 49? Well, that's 7 with a plus in one and a minus in the other. Okay? This example looks kind of funny, okay, because I have a 4 minus j squared, but what's important here is first, is there a GCF? Nope. Is there a difference? Yes, there's a difference right here. Are they both perfect squares, the 4 and the j squared? And the answer to all those questions is yes. So even though it's in a backwards order, I can still do this. Now it's important that I write it in the same order, meaning the square root of 4 is 2, so it must go first. The square root of j squared is j, so it's going to go second with a plus and a minus. M squared plus 64. So is there a greatest common factor? No. Are they perfect squares? Yes. But is it a difference? And the answer to that is no. With a plus here, this is not doable. I cannot say m plus 8 and m minus 8. This right here, because I can't do anything with it, because of the plus, becomes prime. Okay, remember prime means it does not factor in any way. 8. Negative x squared plus 121. Now, right now, are they perfect squares with no GCF? The answer to that is yes, but right now it looks like it's not a difference. But I can actually rearrange this to say 121, because it's positive, minus x squared, and it becomes the same as the one that's right above it there on number 6. Okay, I can reorganize them if need be. Okay, so now what's the square root of 121? Well, 11. What's the square root of, x squared? Well, x. 1 with a plus and 1 with a minus. And we are done. Getting close, guys. These last two examples is all I have left. So, looky here. I want you to try to do this one on your own. Pause it, take out the GCF, and factor it. Alright, so the GCF between 6 and 42 is 6. So when I take it out, I end up with this. Now, I realize that x squared, yes, is a perfect square. 7, though, is not a perfect square, even with this difference. It means that I can't continue. Now, it is not prime because I originally took out this 6. So this becomes our final answer. Alright, one more left to do. A to the 4th minus 81. So first, big question, is there a greatest common factor? The answer to that is no. So I'm going to create my groups here, because it is a difference of two perfect squares. 81 is a perfect square, a difference. A to the 4th, because it's even, is a perfect square. So what is the square root of a to the 4th? Well, that's a squared. What is the square root of 81? Well, it's 9. 1 with a plus and 1 with a minus. Now, this question is actually not done factoring right now. It is not done factoring because this a squared minus 9 is another difference of squares. So this a squared minus 9 will factor one more time to say a squared, the square root of it is a. The square root of 9 is 3. So I have a plus and I have a minus. Now, I have to remember that this is still part of my answer. So I'm going to put that a squared plus 9. Because of the plus, it will not factor any further, and it is done. Hey, if you were having lots of questions as you were doing this today, tutoring, I believe for you all is tomorrow. Yes, it's tomorrow. So if you needed to extra practice other than our online session tomorrow, you are welcome to click the link for tutoring that I posted on Google Classroom and sign up for that. Otherwise, thank you all for tuning into this really long lesson. Hopefully the other ones in the future will be faster. Thanks, guys.